Good morning, students. In previous lecture we have learned about photoelectric effect. Once again we recall what is photoelectric effect and we can enter into next concept, that is Compton effect. So first coming to photoelectric effect. In previous lecture we have learned photoelectric effect. So what do you mean by photoelectric effect? When photon with energy h nu, okay, strikes upon an electron orbital, okay, strikes upon an electron orbital, then what will happen? These electrons absorbs this photon energy and the electrons are emitted out of this atom. This process is called photoelectric effect, okay, or you can say that when photon collides with an atom, then it will strike upon an orbital electron and transfers all its energy to the electron, and the electrons are ejected out from the atom. This whole process is known as photoelectric effect. And this photoelectric effect can be written as, that means this effect obeys the Einstein photoelectric equation, which is given by h nu. Here h nu is the energy, okay, energy of the instant photon. So h nu is equal to E kinetic, that means kinetic energy plus binding energy. So here EKIN represents the what does h nu represents? Photon energy, okay, h nu represents instant photon energy, instant photon energy. And what is EKIN? Here kinetic energy of the electron, and plus EB represents binding energy of the electron. So what do you mean by binding energy? Already I have told you, that means the energy required, okay, to remove an electron from the system is known as binding energy. Then we have explained this photoelectric effect depending upon the binding energy of the electrons which are nearer to the nucleus and which are the electrons which are far away from the nucleus, okay. The electrons which are nearer to the nucleus possess requires high binding energy, okay, whereas the electrons which are away from the nucleus requires they require less binding energy. That means you know that the electrons which are away from the nucleus they are available in free state, okay, whereas here the electrons near to the nucleus possess strong binding energy, because you know that this nucleus composed of protons and neutrons. These protons possess positive charge, whereas the electrons have negative charge. So strong bonding exists between the positive charged proton and negative charged electron, okay, whereas if you go away from the nucleus, the electrons, that means the distance between the nucleus and the outermost electrons will be more, so less binding energy exists between proton and the electron. So anyhow we require high bonding energy to remove an electron from an atom which are nearer to the, that means the electrons which are present near to the nucleus requires high binding energy, whereas the electrons which are present at the outermost orbitals requires less binding energy. So these are and we have given the formula for binding energy for different orbitals and so on. So this is about this is the thing we have covered in the previous lecture. Today we are going to know about Compton effect. Today's concept is Compton effect. Now today's concept is Compton effect. So in this, to explain this phenomena, initially we are going to consider a free electron. Okay, we are going to consider electron. Now, you assume that when a photon of energy, okay, you assume that when a photon of energy h nu incident on the electron, okay, we are considering an electron and incident energy of a photon is h nu. Is h nu. Now, when a photon of energy h nu strikes the free electron, which is at rest position, then the photon energy will be changed. That means the energy will be, there will be a change in photon energy. That means the energy will be observed by the photon, or the energy will be emitted out. So, when the photon of energy h nu strikes the electron which is at rest, there will be a change in photon energy. So the change in photon energy, why we are saying that there will be a change in photon energy? Because both the photon as well as the electron, both will scatter with some angles. So there will be a change in photon energy. Okay. So here, now when the photon of energy h nu strikes the electron which is at rest, then there will be a change. There will be a change in photon energy. Will be a change in photon energy. Why there will be a change in photon energy? Because both the electron and instant photon moves with certain angle. So there will be a change in photon energy. That change in photon energy is represented with h nu dash. Okay. H nu is instant photon energy. What is h nu dash? Change in photon energy. That means after striking the photon energy with the electron, then both electron and the instant photon will scatter with different angles. So there will be a change in photon energy which is represented with h nu dash. Now, as I have said that after instant photon striking the electron, both the electron as well as the instant photon scatters. Now I am assuming that the scattering of instant photon with angle theta. So the change in photon energy is represented with h nu dash. Okay, and even the electron also scatters. So the scattering of electron takes place with an angle phi. Okay, so this we call it as scattered photon. Okay, this is scattered photon. And what is this? This is the recoil electron. Why I am saying that the electron will scatter, and I am saying it as a recoil electron? Because after scattering, again the electron, there may be a chance that the electron comes to its original position. So we call such type of electron as recoil electron. Okay, that means here after instanting, the instant photon scatters with an angle theta, and the electron which is at rest position scatters with angle phi. This whole process is termed as Compton effect. Once again I am repeating, when a photon of energy h nu strikes the electron which is at rest, then there will be a change in scattered photon. Okay, the direction of instant photon. Now the instant photon scatters with an angle theta, whereas the electron scatters with angle phi. This process is known as Compton effect. And here you are clearly observing about the Compton effect. So what I am considering, initially I have considered the electron. Now assume that this electron is at rest. Then we assumed that a photon of energy h nu strikes the free electron at rest. Then both the photon as well as the electron scatters with angles. So the angle for incident photon scattering is theta. Okay, whereas the electron scatters with angle phi. This whole process we are calling it as Compton effect. The figure clearly shows you or describes the Compton effect. Now we are going to consider this Compton effect is maximum around 1 mega electron volt. Okay, that means this process is maximum. That means Compton effect is maximum at 1 mega electron volt. Now as I have said that there will be a change in wavelength also. The instant wavelength is different, whereas after scattering the instant photon energy is also changing. That means from this we can say that there will be a change in instant photon wavelength and scattered photon wavelength. So the change in wavelength is given by the change in wavelength. Change in wavelength is given by, why there will be a change in wavelength? Because the incident photon energy is different and scattered photon energy is different. So as their energies are changing, definitely there will be a change in wavelength also. So the change in wavelength in Compton effect is given by delta lambda. Delta lambda represents change in wavelength. So change in wavelength is represented by delta dash minus delta. So here delta dash represents scattered wavelength, scattered photon wavelength, whereas this lambda dash represents scattered photon wavelength. Photon wavelength. Whereas here lambda you are observing. This lambda represents wavelength of incident photon. Wavelength of incident photon. Incident photon. I think the change in wavelength is given by delta dash minus delta. What does delta dash represents? Scattered photon wavelength or wavelength of scattered photon. What does lambda represents? Wavelength of incident photon. Wavelength of incident photon. Incident photon. Now here delta dash we are calling it as Compton shift. Okay, this delta dash is also known as Compton shift. Delta dash is known as Compton shift. Now here this delta dash, lambda dash minus lambda can also be written as, now as I have said that Compton shift is given as delta lambda is equal to lambda dash minus lambda. So this can be also equal to h by MEC into 1 minus cos theta. Okay, so here delta lambda is nothing but Compton shift or change in wavelength. Compton shift is given by lambda dash minus lambda. What is the lambda dash? Okay, wavelength of scattered photon. Here lambda represents wavelength of incident photon, which will be equal to h by MEC. Here h represents Planck's constant, Me represents mass of the electron, here c represents velocity of light, into 1 minus cos theta. Now this, after substituting the Planck's constant and electron mass of the electron, and here velocity of light, and the theta, that means the scattering angle, and so on. Then the final Compton shift value is equal to 2.42621 into 10 power minus 12 meters. Okay, so after substituting all these parameters like Planck's constant, mass of the electron, velocity of light, and 1 minus cos theta angle, okay, scattered angle, then the assumed Compton shift is given by delta lambda is equal to 2.42621 into 10 power minus 12 meters. Now, this Compton shift is independent of, okay, incident light, okay, incident photon. So, the Compton shift is denoted by delta lambda. It is independent of, Compton shift is independent of some parameters, okay, independent of some parameters. They are instant wavelength, that means this Compton shift does not depend upon instant wavelength, and material of scatterer, okay, material of scatterer. But this Compton shift depends on, some parameters. They are angle, okay, that means scattered angle of instant photon. So you know that instant photon angle is theta, okay, whereas the recoil photon angle is phi, okay. So this Compton shift does not depend upon instant wavelength. It does not depend upon the wavelength of instant photon, but it depends upon the angle of the instant photon. Which angle the instant photon is striking the free electron at rest. So, I think everybody clear. The Compton shift depends upon what parameters? Okay, the Compton shift mainly depends upon scattered angle of instant photon. Okay, scattered angle of instant photon. Whereas it does not depend upon instant wavelength as well as material of the scatterer. Now, here, as we know that it does not depend upon the wavelength. Since we know that wavelength is equal to lambda is equal to c by mu. Okay. So, just I am writing. Here we know the lambda value. Lambda is equal to c by mu. So, just I am going to substitute. Lambda is equal to c by mu in Compton shift. Okay. So, delta lambda is equal to lambda dash is there. So, how can you write lambda dash? C by, how can you write that? C by lambda dash. Sorry, c by mu dash minus lambda value c by mu. So just I am going to substitute lambda value in the Compton shift. So what you will get? Delta lambda is equal to, so lambda dash can be written as c by mu dash minus lambda value, you know, c by mu is equal to, okay, h by mec into 1 minus cos theta. So by sending c by mu to the r, h mu dash, okay, h mu dash is equal to, that means what does h nu dash represents? energy of the scattered photon. Okay. So the energy of the scattered photon can be known by simplifying this equation or by this expression. So h nu dash is equal to h nu by 1 plus 1 minus cos theta into epsilon, whereas this epsilon value is given as h nu by MEC square. Okay, h nu by MEC square. So after simplifying this expression, we will get energy of the scattered photon. So energy of the scattered photon is given by h nu dash is equal to h nu by 1 plus 1 minus cos theta into epsilon. What does epsilon value again represents? H nu by MEC square. Now, depending upon the instant photon energy, we are going to calculate the energy of that means kinetic energy of the scattered photon. Okay. Now, as we have considered epsilon is equal to h nu by MEC square. Now, for very large instant photon energy, that means h nu, we know that incident photon energy is represented by incident photon energy is h nu. Now, if this h nu is very larger than the denominator term, that is MEC square, okay, then the energy of the back scattered photon approaches half MEC square. Okay, that means if the instant photon energy h nu is greater than the denominator term, that is MEC square, then what will happen? The back scattered photon, okay, as I have said that when photon energy incident on the free electron, the electron scatters with some angle and the instant photon also scattered with some angle. Now we have considered in the diagram, theta is the scattered photon, okay, scattered photon, and phi represents the recoil electron. Now what I am saying is that if the energy of the back scattered photon, again back scattered photon means the instant photon is scattering with angle theta, again it will come back to the original position. That means again it comes back. It's nothing but back scattered photon. This back scattered photon approaches the value half of this MEC square. Then the value of this term becomes 0.25 mega electron volt. That means if this scattered photon again comes back, then the energy will be, becomes half, and whose value is equal to 0.25 mega electron volt. And this thing happened at an angle theta is equal to 180 degrees. And if you assume, if this theta value is, okay, if theta value is 90 degrees, then the half MEC square value becomes 0.51 mega electron volt. Now we are considering the kinetic energy of the recoil electron. Okay, so now we are going to consider the kinetic energy of the recoil electron. Therefore, the kinetic energy of recoil electron means after scattering, the electron comes back to its position. It's nothing but a recoil electron. Now the kinetic energy of recoil electron is given by T is equal to h nu minus h nu dash, and which will be equal to h nu into 1 minus cos theta into epsilon by 1 plus 1 minus cos theta epsilon. Okay, the kinetic energy of the recoil electron is given by the expression T is equal to h nu minus h nu dash. That means instant photon energy minus scattered photon energy. will be equal to this expression, which is given by h nu into 1 minus cos theta into epsilon. Again, epsilon means the value is h nu by m is c square plus 1 plus by 1 plus 1 minus cos theta into epsilon. Now this equation represents the kinetic energy of the recoil electron. So the kinetic energy of recoil electron is represented by T. Okay. Now the kinetic energy of the electron will be maximum at an angle theta is equal to 180. So when does the recoil electron, kinetic energy of the recoil electron becomes maximum? At an angle of theta. As I have said that the shift, that means Compton shift, depends upon angle, not on wavelength. So here the kinetic energy of the recoil electron becomes maximum at an angle theta is equal to 180 degrees. And the kinetic energy, okay, kinetic energy of recoil electron becomes 0 at an angle theta is equal to 0. Okay. So kinetic energy of recoil electron is 0 when theta is equal to 0 degrees. At that situation, the wavelength, okay, the frequency mu is equal to, mu becomes mu dash. Now this kinetic energy of recoil electron becomes, that means maximum kinetic energy can be written as T maximum. Here T maximum represents maximum kinetic energy of recoil electron is given by h mu by 1 plus half epsilon. Okay. Here, in this we have considered the photon energy exceeds, okay, the constant MEC square, then its value becomes 0.25 at an angle theta is equal to 180 degrees, and at theta is equal to 90 degrees. What will be the instant photon energy? That is 0.51 mega electron volt. Now we are interested in calculating the kinetic energy of recoil electron. That means recoil electron is nothing but when the photon strikes the free electron, this electron also scatters with angle phi. After some time, again it comes to its original position. Then that electron we call it as recoil electron. Now we are interested in finding the kinetic energy of recoil electron. It is given by T is equal to h nu by h nu dash, whose value is equal to h nu into 1 minus cos theta into epsilon by 1 plus of 1 minus cos theta into epsilon. Now the kinetic energy becomes maximum at an angle 180 degrees and it becomes 0 at theta is equal to 0 degrees. So at this situation, the frequency mu becomes mu dash. Then the maximum kinetic energy will becomes h nu by 1 plus half epsilon. So now we are going to relate theta and angle phi with the equation that means now the angle theta and phi can be related by the equation. Okay, the angles theta and phi. You know what is theta and what is phi. Okay, can be related by the equation, can be related by the expression cot phi is equal to 1 plus epsilon into tan half theta. Okay, so the angles theta and phi, that means the scattered incident photon and scattered electron can be related by the equation cot phi is equal to, okay, cot phi is equal to 1 plus epsilon into tan half theta. Now we are going to consider the energy scattering cross section. Okay, so the energy scattering cross section is denoted by the expression energy of the scattering cross section. Energy scattering cross section. Energy possessed by the scattering cross section. So the energy scattering cross section is denoted by sigma s is equal to h nu dash by h nu into sigma e. So the sigma c. Here the energy absorption cross section is denoted as sigma. Now here, now we are going to consider the atomic Compton cross section, which is given by A sigma c is equal to Z sigma c. Okay, this equation represents the atomic Compton cross section. Now this scattering is coherent when h nu is equal to h nu dash, and this scattering is incoherent when h nu does not equal to h nu dash. So here we have considered the atomic Compton cross section, which is given by A sigma c is equal to Z into sigma c. Now here this scattering, that means atomic Compton scattering, becomes coherent when h nu is equal to h nu dash, and this atomic Compton scattering, okay, is incoherent when h nu does not equal to h nu dash. Now we have considered the overall atomic differential Compton cross section, which is given by A sigma of theta is equal to, that means this atomic cross section is the sum of both coherent and incoherent. So the overall equation is A sigma of theta is equal to A sigma coherent theta plus A sigma incoherent theta. So this equation represents the atomic differential, okay, or total atomic differential, or total atomic Compton cross section. So the overall, the total Compton cross section is given by A sigma of theta is equal to A sigma coherent of theta plus A sigma incoherent of theta. So this is about the Compton effect. Thank you.